All right. So, thank you. And so today, we don't have any new material to cover. We're going to be going over examples, questions you guys have kind of leading into the exam on Thursday. So kind of where we're currently at. So what's due at the end of the day today? Yeah, third problem set. So as many submissions as I had hoped up to this point. I was hoping you would kind of get working on that early so you kind of finish that up and start preparing for the exam. If you're kind of finalizing that submission is due by the end of the day today. So what I would like to do is tomorrow when I get to my office, I'll post kind of the answer key or the do file to that third problem set. So you can start to see kind of what the answers would be. Now, obviously, when it comes to maybe obviously, but the exam, I'm not asking you any coding questions, right? So that code, it's not like you're going to have to like give me RAG or give me the, exact regression you would run. But a lot of those questions had some follow-up questions from the state output. They might be some good ones to kind of review going into the exam. So the exam is going to look more like is that practice exam where I'm giving you kind of the output, and I generally will attach the code associated with it. So it's like what the code you would have ran is, but then using the statistics that you see in that output to answer kind of then a certain number of questions, right? Now, sometimes I might leave some things out so that we have to know, okay, maybe there's certain statistics here I can use to fill in kind of what's missing. And I'll try to kind of mention that as we go through some examples today, what that could look like. But that would be some additional good practice. So I kind of said, what's the first thing that it was me I would do going into the exam?
Formula sheet.
Yeah, I'd have this formula sheet. I'd have written down next to it what every single one of these equations represents. Right? You may not need all of them, right? You may not need to use all of these equations. These are just anything that I've shown you in the slides that potentially could be helpful in understanding the material that we're going to be looking at or the questions that you would have to answer. So, for example, like when you're seeing things like this, I'm not going to make you sit down and calculate the total sum of squares or the explained sum of squares. But we did need to kind of know what those represented when we were calculating things like our R squared. So it's unlikely you're going to actually have to use these equations, right, in terms of actually calculating these values. But we need to know what they represent, the amount of variation that I can explain with my model, total amount of variation that exists. The ratio of those two gives me my R squared. So not every equation in this formula sheet is going to be like guaranteed that you're going to have to use, but this is anything that we've looked at kind of in this first half of the semester, okay? So some of them are going to be probably more applicable than others in terms of answering questions, and we'll kind of see as we work through some today. I'll probably try to show you what formula we would be thinking about and kind of connect it to the question that is being asked. But I would kind of try to at least think about what each of these equations represents. And I kind of have this formula sheet that I'll have on the exam, and even though it won't have anything written on it, when I give it to you on Thursday, hopefully, if you've been studying from a formula sheet where you've written this out, you can kind of remember, oh yeah, that's my displaying sum of squares, or that's my standard error for my coefficient estimate, et cetera. Okay? So I would kind of do that first. I would then be able to kind of work through every single question in that practice exam and kind of provide a solution as to why the correct answer is what it is. Not just kind of sitting down and taking it as though it's a practice exam, but actually being able to work out every single one of those questions and why the correct answer is what it is. Okay. After I do that, what would be good to go back to? Well, I'm putting out that the solution to the third problem set, because I probably think that might be worthwhile, right? Working through or looking at those solutions to those problem sets. Some of those questions that were like off data might be some pretty good ones to review as well. And then in addition to that, I go back to old quizzes, right? Old practice problems that we had and review those, right? That's quite a bit of material, right? If you get through all that and want more, look at some of the in-class quizzes, in-class practice questions that we looked at that weren't for points. But I think that should kind of keep you pretty busy, okay? So before I kind of ask for specific problems, just mentioning some details about the exam. So kind of looking at some of the results from that survey, which most people did. And if you didn't, I hate seeing people leave points that they can get added to the exam out on the table, but some of you didn't answer that. So you didn't get those 3 points that'll get added to your exam, right? But it looks like I think the vast majority would prefer kind of a mixture of in-class and take-home, which is kind of what I anticipated. So the in-class portion of this will be a quiz, what looks like a quiz pop up on Canvas. It's going to be 11 questions, each worth 3 points. So these are mostly multiple choice. There's a couple like numerical response, looks kind of similar to the quizzes that you would see of these first 3 quizzes we've taken. I think that those should be easier questions. So if you take that take-home portion seriously, I'm not having you set up a webcam, so you should be able to use what?
Yep.
Your notes. I would have notes in front of me. I would have anything that I've written down maybe as I was studying for the exam to kind of reference. Once you start, you'll kind of have 60 minutes to complete those 11 questions. So, you're roughly talking about what? About 5 minutes per question. I think that those are going to be probably easier than what you even see. Some of the questions on the exam will be easier, some of them will be harder. But I think that take-home portion should be a really good way that most of you can help boost your final grade on the exam. Okay. So 33 points from that, which means how many points would then be on the take-home portion? It's out of 100. 67, right? So hopefully we can do that math. Otherwise it's going to be rough Thursday. But I actually have kind of the in-class portion. It's going to be 6 questions with multiple parts to each one. So there's like A through C or A through D. Each one has like about 4 parts, but some have 3. I think one has maybe 5. One of the questions might be a little bit easier. And it's worth a total of 70. So if you got every point or every question correct, you get a total of 103 points. Right? So 70 plus 33, 103. In fact, if you did the pre-exam assessment, you get another 3 points there. You technically get 106 out of 100 points on this exam. Now, maybe I'm adding these things in because I know these exams are hard, right? So when you get your exam score and you start asking me about curves and things like that, I'm kind of giving you an anticipatory curve of what? 6 points, right? So, I understand this is difficult. I understand we have a lot of material. Once again, take that take-home portion very seriously. And I think you can really get a bulk of those points, majority of those questions right. The in-class portion is probably going to be a little bit more where I'm really testing, how well do we understand these concepts, okay? And it's going to primarily be open response. So I tried to put as many times in the exam. I know you don't have a lot of time to read through in detail the instructions, so I'm saying it now. Anytime you're asked why, or you give me a response, what's probably a good way to get partial credit? Show your work or give a reason as to why you're answering that, right? So show as much work as possible. When I'm asking you why, detailed as possible, right? I'm grading a partial credit for that in-class portion, right? The take-home portion is all or nothing, right? They're multiple choice or numeric. So that, doesn't really matter if you show your work. There's really no place for you to show me your work. In class, you can write on the exam. You're showing me all of your work on the exam. Show me as much as possible. Any other logistical questions? So the only other thing I haven't really mentioned up to this point, I got to thinking about, I think it's self-explanatory, but don't think that it necessarily is to everyone. I'm not dumb and I understand how graphing calculators work. So do you think I probably allow you to have one or not for this? No, I know you can store notes like I wasn't born yesterday, right? So you need to have a scientific calculator is fine, right? Something fairly rudimentary. Nothing that you're going to have to do is anything more than addition, subtraction, division, multiplication. So a 4-function calculator would work, right? If you have a calculator, I'm not asking you to go out and buy a 4-function, right? But anything that has non-graphing capabilities, you can use, okay? Other than that, something to write with. I'll have plenty of blank paper if you need extra space other than what's provided on the exam. We'll try to get going right at 2:20. I'll have everything ready to go. If you guys are all here kind of ready to go, I'll get that handed out so I can kind of give you as much time as possible, okay? Other than that, any logistical questions before we dive into material here about the exam?
Okay. I don't know if this is a logistical question though, but Professor, you told us that joint hypothesis test isn't coming for the mid. I mean,
No,
it's not, right?
no, it is on the midterm.
Oh, is it?
I
Oh,
told you it wouldn't be on that 3rd quiz, right? Because that quiz was due prior to when we covered it in class.
okay. Because last class I thought you told us that joint hypothesis test isn't on. Okay, so. Got it. So F statistic would be coming on the.
Yep, so I said that was the last new material that we talked about last Thursday. So anything we've talked about is fair game.
Okay.
It wasn't for the quiz 3 because quiz 3's due date was prior to us covering that material.
Okay.
Other logistical questions.
When would the take home portion be due?
So I got it set to be due the end of the day on Monday. That's a good question. So you'll have, a couple days to figure out what works with your schedule. You could take it Friday, take it Thursday after the exam if you want to get it out of the way. You got all of Monday. Yes, you could do it on the weekend. I'm not expecting that of you, but I know when I was after I was out of college, I work on the weekends anyway. So I use them as days to work. So whatever works for you in that quite a few days there. Now, if I'm studying, I might try to do it pretty close to Thursday, right? Like the further out you get, if you don't spend more time studying, it's not going to probably help you to take it on Monday, but technically up until the end of the day. Well, and I say the end of the day, Monday is when it needs to be submitted. So if it's due at 11:59, you need to start it by 60 minutes, 10:59 on Monday, Eastern Standard Time. Okay. It's a good question. Yeah.
Since that's online, will it be like our quizzes where we know immediately what we got on that section?
It won't show you until after the due date passed. Well, it might show you your score, but it won't tell you which questions you got right or wrong. Yep. Other questions, logistical. Okay. How are we feeling about this? Saw the responses. They're mixed, right? So hopefully today will be helpful. So any specific questions from anything? I think the practice exam is probably a good place to start, but any questions that you have? I saw you and then we'll go over here.
Can you go over number 22 on the midterm practice problems?
Yep. So this is some newer stuff, so probably good to review. So I've got here whether or not a free throw was made. So this is just a dummy variable. That's our dependent variable. And I have all these independent variables here on the right-hand side. So what is the F statistic for whether or not the added variable? So this one kind of goes back to, I think we're thinking about this original naive regression where we only included kind of what category this shooter was, right? Freshman, junior, senior. Now, I'll mention some things along the way because I wrote the exam, so maybe this is important. Why did I leave out sophomore? If I had included it, what would have existed? Perfect multicollinearity, right? So I had to leave one group out to make that my base group. Right? So if I ran this regression, I then said, okay, my R squared is what? 0.0369, it looks like. If I then said, what is the F statistic for whether or not the added variables had any joint significance? And I added in what? Game, minutes in the game, whether the home player, score differential, attendance. So we didn't go through this as much, so I may not be as focused on how to do this, right? But I'll mention the things I would focus on. So we've got two regressions. What are we doing when we're testing for joint significance? We're testing to see whether or not the added variables added any significance to our model, which we were looking for in terms of did it increase the R squared by a statistically significant amount? We always know that when I add more variables, what's definitely going to happen to the R squared? If I ask you a question on the exam, this should be an easy one. We know it has to go up. We even looked at an example where maybe it only goes out to like the 6th decimal, but we know it's going to increase, right? So we want to know, was that increase statistically significant? And then I know if I just add more variables, I can always get a higher R squared. So our F statistic kind of controls for, yes, I saw the R squared go up, but if I added 100 variables and it only barely went up, it wasn't really a very statistically significant increase. So our F statistic is trying to calculate that. So what are we looking at? That difference between our unrestricted and our restricted model. The unrestricted model is where we've added in these additional variables. The restricted model was the initial one where we left them out. So how could I calculate this F statistic? So once again, probably would focus a little bit less on this, but if I had the output, what I could do is I have my unrestricted R squared is 0.0613. The restricted R squared was 0.069, 0.0369, okay? And in fact, no, I don't want insert, I want here. Zoom. do one page just so it's. So down here. 0.0369 was the restricted R squared. 0.0613. Might be too big, but here we can actually see it. So I've got my restricted and unrestricted R squared. I can plug those values in. I've got my unrestricted R squared was that 0.06 value or whatever it was. So the only other things I would need to compute the F statistic here would be Q, N, and K. What's the easiest one of those? N is simply my
Duration.
sample size. So I can go to that output and say my sample size was 100. Now, K is going to be the total number of variables I included in my unrestricted model. So how many total variables do I have here? 1, 2, 3, 4, 5, 6, 7. So I plug K as 7. Now Q is going to be the number of restrictions. So in my new model, relative to the old one, how many variables did I include? 4. Now it's just a matter of getting that entered in my calculator. Right? So I'm probably less likely to ask you to calculate an F statistic and probably lean a little bit more heavily on kind of the interpretation of it and things that will change it. So I might add some questions in here to think about this. All right. So if I have my F statistic, right, if I calculate it, how do I know whether or not I have joint significance? Maybe I give you the output from Stata, which runs this joint significance test for you, tells you the F statistic, and tells you the corresponding p-value. So what I need to remember is when I'm doing this joint hypothesis testing, what I'm assuming is whatever coefficients are associated with the variables I included, I'm assuming that they are all simultaneously equal to 0. So I'm assuming there's no additional explanation from these 4 variables. So when can I say that they actually did have a statistically significant effect if I can reject that null? When can I reject any null hypothesis if the p-value is less than alpha? What 3 levels of confidence are we going to look at? 90, 95, and 99%. If these are my confidence levels, when we talk about them in terms of statistical significance, these correspond to 10, 5, and 1. So if I ever leave it open-ended and ask you what levels can you reject at, you can tell me either the confidence levels or the statistically significant levels. So you don't have to tell me both, you can just tell me one. Okay? Now, what would my corresponding alphas be here? 0.1, 0.05, and 0.01. So I would simply be looking at what that output from Stata was that gave me the F statistic, gave me the corresponding p-value. Whatever levels I can reject at, I'm rejecting that there is no statistical significance of those added variables, right? So I could also flip this, and let's say I found a p-value of 0.02. What levels would I say that these added variables had no statistical significance at, or had no explanatory power? So it's 0.02, less than 0.1. Yes, so I can reject. What am I rejecting? I'm rejecting no statistical significance. Well, if I just asked you which levels do they have no statistical significance, if I'm rejecting it, not at that level. Right? This I'm actually saying I'm rejecting no statistical significance, or saying they actually had a statistically significant effect. Right? Is 0.02 less than 0.05? Yes. So at that level, I would say they did have statistical significance, right? That the explanatory power actually increased. So what levels would they not have any statistical significance? Is this less than 0.01? No. 0.02 is greater. So I would fail to reject. If I can't reject this at the 1% significance or 99% confidence level, I can't say that these added variables had any additional explanatory power. So kind of remembering what we're actually rejecting, right? That there's no additional explanatory power. All the coefficients are equal to 0. And then you've got to be, I mean, this is going to apply to several problems. We've got to be able to compare that p-value to our alpha. If p-value is less than alpha, we reject. If it's not, we fail to reject. Okay. Is that questions on that? And did that answer your question? Like I said, I know it asks you to calculate, which you can, and I think I've got it in that solutions file. You're really just plugging those values in. The kind of tricky things there is that unrestricted R squared, that's the one that included all the variables, right? And then your K is the number of variables included in the unrestricted model. Q is the number of restrictions or the number of variables that you added in. Okay. So what I would think about, maybe another question, I'm not sure if this is on the practice exam or not because I don't have it memorized. But if my F statistic is what? R squared of unrestricted minus restricted over Q. And then this is what? 1 minus this. I hope I'm right from memory here. You've got the formula sheet in front of you. So if I made an egregious error, let me know. But what if instead of those 4 added variables, let's say I included 6. So if I include more restrictions, that's going to increase Q. Now it's also going to increase K. We'll hold off on that for a second because I think it's easier to think about it this way first, and then I'll kind of add in some. If I increase the number of restrictions, what's that going to do to this fraction? It's going to make it smaller. Now, it doesn't matter what this is. If the numerator is smaller, my F statistic is going to be smaller. Now, this is why I said if I ask you a question about the number of restrictions and how it impacts your F statistic or how it impacts the statistical significance, if I increase Q, what's going to happen to K? It's also going to go up. But if I'm subtracting a smaller, or if I'm subtracting a larger value, what's happening to this? It's going down, right? Which would then do what to this fraction? Make it bigger, which would do what to my F statistic?
Make it lower.
So it'll have the same impact. So to make it easier, just worry about how the number of restriction impacts Q. Because it'll always have the same impact on K. We might as well just focus on Q there. And K can never, I'm never going to be able to add a restriction without increasing K, okay? So I would just focus on, if you're thinking about the number of restrictions, you can just think about how it's impacting Q. Okay? So if I have a smaller F statistic, what's going to happen to my statistical significance? So it doesn't matter if I'm looking at a student T distribution for simple sample coefficients, or if I'm looking at an F statistic for that difference between my R squared. It's just a different test statistic. It's going to come from this distribution. Now for the F statistic, it's a little bit easier because when my F statistic goes down, my p-value is simply the area to the right of it. When I had a sample coefficient where evidence on either side could go against, I said my p-value would be the area to the right, but then times 2. It doesn't really impact our directional changes, but here it makes it a little bit easier. We can think about this as our p-value. So if our F statistic has went down, right? I said that earlier when I added more restrictions. What's happening to my p-value? It's going up. So if I reject when the p-value is less than alpha, if my p-value is higher, when I add in more restrictions, am I more or less likely to reject than I was before? The p-value is higher. Is it more or less likely it's going to be less than alpha? So this is where, if directional changes trick you, put numbers to it. If I had a p-value of 0.02 before, and that was less than 0.05. If my p-value is now 0.2, it's went up, it's less likely it's going to be less than my alpha, or I'm less likely to reject. If that number gets higher, it's less likely it's going to be less than alpha, so I'm less likely to reject. So if the arrows don't make, put some hypothetical values to it to kind of make you see, oh yeah, it's less likely that it'll be less than alpha there. Okay. And this is the idea that when I add in more restrictions, I just add more variables, what's going to happen to R squared? I know that it's just going to go up even higher. So our F statistic is trying to say, yes, I know you added a bunch of these variables in, but it's almost like I'm looking at the per explanatory or the explanatory power per variable, right? That's kind of what our F statistic is trying to control for. So if I simply add in more restrictions, I know the R squared is going to go up. F statistic kind of controls for that. And potentially, just because I added more restrictions, it's now gonna make it even harder. I can reject the null, or even harder to find statistical significance that R squared went up. So know how the number of restrictions impacts your F statistic and the corresponding ability to reject the null, your statistical significance. Like, so I know there's a question about that. Okay? Any questions on anything here? So going along with this will be kind of a reoccurring theme I've tried to use or mention throughout the whole class. So if I have my test statistic or just a simple single coefficient. We said our standard error, we've got an equation for it, but we're minimizing kind of our residual squared, and that's going to be over n-1. So I can think about anytime I take a higher sample size, I should be able to think about things that are going to change. So if I take a higher sample size here for a single coefficient, not a joint hypothesis test, just for one single coefficient, what's going to happen to this fraction? So we said, as I take higher sample sizes, what happens to my distribution of those sample coefficients I'm estimating? It becomes smaller or more peaked, right? Narrower, right? So it's less likely I'm going to see extreme values, right? That are further from the true value. So when I have a higher sample size, essentially saying it's more peaked or like more narrow, I'm saying that the variance or the standard deviation of that statistic is lower. That's what my standard error is, right? Our standard error, I said one way to think of it was really just like the variance or standard deviation of our sample coefficient estimate. So it's going to become more peaked. So what's happening to my standard error when the sample size goes up? A larger denominator. It's going to decrease the standard error, more peaked distribution. So then finding the same sample coefficient is going to result in what? A higher or lower test statistic? Higher. Which if I'm looking at a higher test statistic, what's true about the area to the right of it, which represents half my p-value? It's getting smaller. So now is it more or less likely I can reject the null? Now, the less intuitive result might be that when I'm looking at my F statistic, here I'm not writing these things in because none of them have the sample size, right? And we're just going to focus on the sample size. If I have a higher sample size, what is that going to do to my F statistic when I'm looking at the difference between my R squared from the restricted and unrestricted model? Higher sample size will do what to this fraction? I'm dividing by a smaller number, right? So I have like a fraction over this. What's going to happen to my F statistic? If my F statistic increases, we said before, it's the exact opposite effect. Now, my F statistic is increasing. So the area to the right, which represents my p-value, is now getting smaller. So is it more or less likely my p-value is less than alpha? Higher sample sizes always make it, whether I'm looking at joint significance or single coefficient significance, more likely I can reject the null. And this is an intuitive result. We can walk through the steps, or if you can remember intuitively, when I have more observations, right, that's just going to be stronger evidence of whatever I found is in fact accurate. Right? So whatever I find, it's more likely I can reject that coefficient or jointly the coefficients are equal to 0 because I just have more observations now that tell me that. Well, you can walk through these steps if that helps, right? To not just rely on memory or intuitive. These equations on that formula sheet. So if we think about, I was coming up with those off the top of my head. But here's my F statistical equation. Here was kind of my, where is that? Test statistical equation where that standard error, and I put n-1. It's n-2 because we have a constant and a coefficient there. But it doesn't matter, right? We're just trying to do the directional changes here. So the same implication would happen if I had a higher sample size. Any questions on that idea? Well, I would know how to reason through having larger or smaller sample sizes and how that would impact your statistical significance, either single coefficients or for joint significance.
It's not exactly related, but it says on quiz 3 that if you have a larger sample size, adjusted R squared decreases. Can you go through why that is?
Yeah, so for most things, a higher sample size is, well, actually, this is really I'm supposed to say it, but a good thing, right? It makes it more easy to reject the null. Our adjusted R squared is a little bit different, right? And that's because we have to think about what we were doing with our adjusted R squared. We were kind of penalizing ourselves, saying, look, I know that if I ever just add in more variables or I take higher sample sizes, I can always find more statistical significance. So our adjusted R squared kind of penalized us for that. So if we look at that equation for our adjusted R squared, looks like it's going to be right here. So I'm going to write this as 1 minus sum of the squares we can't explain divided by the total sum of squares. And then we had that multiplied by this factor.
You gotta switch.
I know, I'm writing, I'm just making sure that I get, right, match up with the formula sheet. So you guys are seeing exactly what you see in that form. Because there's a different way of writing this squared. But this is the way that you'll have on that formula sheet. So here, it works a little bit different because we had this factor that we were kind of penalizing ourselves when we took higher sample sizes or had more variables in the regression. So I could also ask you a question twofold, right? Did you say it was a sample size increase?
Yeah.
So if I increase my sample size, this one is a little bit tricky because I've got n in my numerator and my denominator here. This is where the thought experiment you might want to use to kind of help. Let's say, to make it simple, like I'm subtracting 1 on top and then something greater than 1. So let's just use like numbers like 10 over 9 as opposed to 100 over 99. What's happening to this fraction as n goes up? It's getting closer to 1. It's getting closer to 1, actually getting smaller. So when I take a higher sample size, this adjustment factor is going down. It's getting closer to 1. If it was 1, what would this actually represent? Well, this is 1 minus the proportion I can't explain. Right? The residual sum of squares over the total, that would be 1 minus the proportion I can't explain. What would that represent? Well, that would represent the proportion that I can explain, or my R squared. So we're adjusting this proportion we can't explain. So the adjusted R squared, if I ever had n was, I mean, I can't actually get it to be equal to 1 because I would have to have an n of less than 1. It's not possible, right? But as it's getting closer, n is getting smaller and smaller, or sorry, n is getting larger and larger. This is getting closer and closer and closer to 1. So my adjusted R squared, as I take higher and higher sample sizes, is getting closer and closer to my R squared, right? So when n goes up, that scaling factor goes down. When the scaling factor goes down, I'm subtracting a smaller amount. So what would be happening to my adjusted R squared? Subtracting a smaller amount, my adjusted R squared would actually be going up. And what is it going up to? It's approaching my R squared. So if I could take an infinite sample size, my adjusted R squared in theory would exactly be equal to my R squared. Now we can't have an infinite sample size, but that's the idea.
So if you have a higher sample size, it would increase
It should,
adjusted R
if
squared?
we have a higher sample size, right? That should increase my adjusted R squared.
Because I chose increase and I got it wrong. So I think that's where I was.
I can look at it. So is it asking you about what happens to your adjusted R squared?
Yeah.
I'll take a look at it there. It might just be saying correct. Did I ask you which one is true or which one's not true?
It's just like a sentence and you just chose
I can
increase.
take a look at it. But I mean, that's the thought process, right? If my n goes up, this factor is getting closer to 1. If I'm subtracting something smaller, my adjusted R squared is getting closer and closer. Now, if I ask you about the gap, right? The gap is not going up. The gap is actually getting smaller between adjusted R squared and the R squared. Yep. Any other questions on that idea? Yeah.
So it's the last question on the third quiz.
Okay.
It mentions specifically that in the new higher sample size, you find the same R squared value. I don't know if that.
I'll take a look at it and I'll put an announcement up, but I'm guessing there's some, if I added in an assumption, Well, I said you found the same R's. I would assume I'm asking you about the gap in between the adjusted R squared and the R squared, but if I wasn't, it might have been incorrectly written. I can kind of take a look at that. But this would be kind of the thought process that you go through with the adjusted R squared. And I'll pull it up here in just a second so we can take a look at it, because I want to make sure that I make this point so that we're making sure we're focusing more, make sure we have this down for the exam, right? So I've got the effect of this sample size, right? What's the effect? Let's instead say I simply add in more variables into my regression. Now, this is the one where if I have the same exact R squared, right? But I've done so by having to add in more variables. So I'm assuming that when I added in more variables, the proportion that I can't explain didn't change at all, right? But if I had to add in more variables to find that same explanatory power, what happens to my scaling factor now? Well, if K goes up, if I'm subtracting a larger value here, what happens to my denominator? It goes down. If my denominator is smaller, what happens to my scaling factor? If I'm subtracting a larger value, what happens to my adjusted R squared? It actually goes down. So this is the idea when I add in more variables, that scaling factor is going to penalize my adjusted R squared. So increasing K, the number of variables I added, as long as I gave you the added assumption that the R squared didn't change at all, we know the adjusted R squared will be less than before. And then said differently, the gap in between our R squared and adjusted R squared would have to be getting larger. So those are kind of the two impacts. I would know how to reason through how that's going to impact your adjusted R squared. And then also, because you know the adjusted R squared is really just you're scaling that R squared, any directional change you see in that is either moving you, if it's lower, it's moving you away from the R squared value. If it's increasing, it's moving you towards that R squared value. The actual, the unadjusted R squared. Any questions on this before we keep moving here? I'll get that third quiz pulled up. And then you had a question over here, so I'll get to you next. I saw you. So we'll let me take a look.
I had the same question
Okay.
about the quiz, actually.
All right, let me see. So we're looking at last question.
Yeah.
So the estimates of slope coefficient, blah, 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 same R squared value, your adjusted R squared will. So here I've got higher number of observations. If I have a higher number of observations, that should get me closer to 1. Tracking something that's smaller should increase. Let's see here. No, correct. Answer set incorrect, right? I've got the same R squared, the adjusted R squared. If I take a higher number of observations, adjusted R squared should increase. Yep, I will change that when I get done with class and kind of get the scores updated accordingly. Yep. All right. Any other problems that people want to see worked through? So I'll go here and then we'll kind of snake around here.
Yeah, in the same question, if we, instead of just more number of observations, if we just had if we increased K, and then the adjusted R score would decrease.
So there's, I think, a question on the quiz where it's like the variable was like important or something. So in that case, would it then increase also like the R squared?
The variable was what?
If it was like related or something. I think it was on the quiz. And then one of the answers, I think the correct answer was like cannot be determined. That quiz pulled up, but
Question 5.
5. It's the question 5 here. So here I'm thinking about predicted. It's actually for. Yeah, so I probably wouldn't be that mean on the exam. So what did there? I had added variables.
Yeah.
So if the added variables do what to my adjusted R squared?
increase it.
Increase it. If I didn't give you the added assumption that the R squared changes, what do you know happens to the proportion that you can't explain as you add more variables in?
Should go down.
So remember R squared, yeah, as you add in will always go up. So the proportion you can't explain would always go down, if I'm subtracting a smaller amount, these are working in opposite directions, I couldn't determine that, right? Probably won't be that. I won't go that because you won't have materials with you on the exam, right? That's why I would add in the kind of the added, I have the added assumption in where let's assume the R squares stay the same. Let's just hone in on what the impact of that change in K would do. Is that what you're
Yeah,
asking?
exactly.
Yep. And then we had here, and then we'll kind of, unless it's related to this one. Yeah.
Can we go over number one?
Yeah.
On the practices.
So. Yes, this is going back a ways. Right? I'm thinking about the relationship of the mean to the median. So if I've got negative skewness, right? Anytime I have skewness, I'm talking about either positive or negative, right? Positive meant it was kind of skewed to the right, or that there must have been really extremely high values pulling the mean to the right. So if I have negative skewness or left skewness, we said one way we can remember this is left or negative skewness means that that mean is less than the median. If I have right skewness or positive skewness, right? I see a positive value, that's telling me the mean is greater than the median. So there might be a question, wink, wink on the exam, where you have to know what that relationship of the mean and the median tells you about skewness or vice versa. If I have a positive skew or it's right skewed, that means it's pulling the mean. So if you can think about the name of the skewness, it's always referencing what it's doing to the mean. So a positive or right skew, it's pulling the mean to the right, not impacting the median as much. So the mean must be greater than the median. If I have left or negative skewness, it's pulling that mean to the left. That means my mean must be less than my median. Right? So kind of that sign or directional change of the skewness we could get because we had this output here. So we know the skewness is negative. So I know that my mean must be less than my median there. Other questions? So once again, there'll be a question about skewness. More than likely. Wink, wink. And then we had a question next.
Number 3 on the quiz 3, I chose alcohol per capita GDP, and average years of schooling just by looking at the confidence intervals, but I got per capita GDP wrong.
Yep. So why did you get it wrong, right? So what you try to do, which was probably smart, is I left some things out here. So what did I leave out? I left out your test statistic and your p-value. If I gave you the p-values, it'd be pretty easy to figure out what's statistically significant at the 99% level, because I would simply do what? Compare the p-value to what value? 0.01, right? It's less than 0.01, I can reject. Now, you didn't have that, so what did you probably try to use? Our confidence intervals. We said every value in our confidence interval, if we run a hypothesis test, we should be failing to reject. So if 0 is not in our confidence interval, that means that will be a value that we can reject. The problem is, did I ask you for the 95% confidence level in this question? No. We're looking at the 99. So confidence intervals here aren't actually useful to me either. So I can do one of two things. How can I come up with my test statistic here? So if I look at my formula sheet, my test statistic is simply taking that coefficient and dividing by that standard error column. Right? What I would then do, and I don't think I put it on this practice exam, what I will do on the actual exam is I'll tell you the 3 values that we would want to compare to for our kind of 3 typical statistical levels. So when we're looking at a 2-tailed test, for our 90, 95, 99% level, that's going to be 1 point, rounded to second decimal, 1.65, 1.96, 2.58. So there, if I calculate these test statistics, what I'd really be looking for is which of them have a test statistic, which in absolute value is less than the absolute value of my critical values, which we said were 1.65 for that 10% level, 1.96 for the 5%, or 2.58 for the 1%. Now, what could I have also done instead of using this test statistic? So maybe I be harder for me to do this. But maybe all I give you are the confidence intervals just to kind of make the point. Let's say I asked you to build for me the confidence intervals. How do I make confidence intervals, even if it's not for a sample coefficient, but let's say it's just for a sample mean. So when I build a confidence interval, I'm wanting to get a lower bound and an upper bound. I'm building that around my sample statistics. So whether that's a sample mean or a sample coefficient, right? What I'm doing is I'm taking that sample statistic and I'm going a certain number of standard deviations to the left and to the right. Well, I know the number of standard deviations the way I need to go are these values right here. So let's say I wanted the 99% level. I would go 2.58 standard deviations to the left to get my lower bound, 2.58 standard deviations to the right to get my upper bound. If I'm looking at my sample mean, then I would simply multiply that by, oh, sorry, I should write this notationally correct. This would just be the standard deviation of my sample mean. If we're looking at a coefficient, how do I get the standard deviation of my sample statistic? We now refer to as that standard error, right? So either way, I could build those confidence intervals, and I'll give you, like I said, in the very front sheet of the exam, I have printed out those three values, right? So you could always build for me a confidence interval, whether it's for a sample mean, which maybe I'll ask you to do that, or you could also do the same thing for a sample coefficient, right? It's just for the sample coefficient, instead of simply using the standard deviation, we have to remember what represents, once again, not technically quite correct, but what represents the standard deviation of our sample coefficient. That was our standard error. Yep. And then if you build those, you'll see that one of them, 95% confidence interval, didn't include 0. But if I go to the 99% level, what has to be happening? What has to happen to the size of my confidence interval? It has to be a little bit wider, right? I'm using higher values, and so then it probably does include 0 for whichever variable you went with that didn't end up being the right answer. Is that?
Yeah, that matches.
Any other specific problems people wanted to see through here? Okay, we're all gonna ace the exam. Nobody has any other problems?
I don't know if you're like allowed to tell us, but for the open-ended, can you give us like an example of like what the problem's gonna be like and different parts to it? So is it like one problem and then like A, B, C, D all related to that one problem, like stuff?
Yeah, so what I try to do is give you a setup where I'm not restarting every single problem, right? So you might notice like on this one, I give you some output. Questions 4, 5, and technically 6, kind of all referencing the same output here, right? So when I say there's 6 problems, it's like 6 problems where you're really getting like one set of regression output and then being asked 3 or 4 questions about it. So you're not having to like restart with completely new variables every single, and in fact, even when I kind of go from like questions 1 to 2, I might change the dependent variable, but use some of the same independent variables on the right-hand side. So we're not just like completely restarting from scratch in every problem.
Okay, so each problem is gonna be like a regression output that you give us and like questions based on that. Okay.
Yep.
Yeah.
So like I said, I mean, that's, what I try, and like I said, like this one, technically I could ask you about a change in sample size from any output, right? So there are going to be some questions where it's not necessarily specific to that output, but it's still using that same idea. If I started with this observation size and I went to 100, right? This question is still related to this output. And then, the next one, I might give you kind of this, and then you can use this to answer, or sorry, I'll give you like here, I gave you a regression equation. You're asking, here 9 and 10 are related to that. Now I'm just taking that same, I'm building on it a little bit, asking you if you added in this variable of income. So, it should be, like each problem is like, is all going to be like A, B, C, and D will all be related to kind of the same output, or at least the same variables there that you're looking at. Is that what you're?
Yeah.
Yeah.
You walk through a problem set where it's like you have to kind of find the values that you didn't give us.
Yeah. So I would. The ones that I asked you on problem set 2, something like that. I would think about, I'm probably less likely to do something with a complete question where you have multiple things that you have to fill in. And more so leave some things out of certain regressions. So I'll kind of touch on a few things that you might need to know how to calculate if I left some things out. Is that sound fair?
Yeah.
So let's say I was looking at 12, just because it has more variables here, it'll kind of help us out a little bit. Let's say I didn't give you the R squared here, or the adjusted R squared. What would I use to come up with my R squared value? Well, I've got my formula sheet. If I've identified what these things represent, this was the sum of the squares or the variation that my model explains, the variation in the residuals or that my model doesn't explain, and then the total amount of variation. So we said our R squared is going to be what's the proportion of the variation my model explains relative to the total variation. So if I'm looking at my stata output, how would I calculate my R squared here? So this is where stata doesn't always match up with our equations. But if we think about what those words represent, it'll hopefully, like, just because there's a letter difference, it represents the same thing. So the explained sum of squares is the amount of the variation that my model explains, right? So stata says it as model as opposed to explained. Okay? So my explained sum of squares would be right here. My total sum of squares is this. So how would I find my R squared? 64 over about 400. Right? Now, if I could also ask you, not for the R squared, what proportion of the variation does your model not explain? Well, I could do it 2 ways. If I find my R squared, one minus that, or it's the proportion of what's in my residual or what my model can't explain over the total sum. Either way, if I do this, I should get the same thing, right? Because my model's sum of squares and the unexplained sum of squares, these should always add up to my total, right? So 64 plus 334 gives me that 398. So I could leave out the R squared, and from those statistics, you could then calculate it for me. Or maybe I leave out this entire standard error column. And maybe I don't give you the confidence intervals just to make this a little bit easier. If I leave out my standard errors, how could I find for any one of those variables what my standard error is? Well, what's something that I have that needs both the coefficient and my standard error? My test statistic. So if my test statistic is that coefficient divided by the standard error, if you tell me any 2 of these, I can always tell you the missing value. So if I left out the standard error, but I gave you the test statistics and the coefficients, it's just a little bit of algebra there. So those might be 2 things I could, wink, wink, do, right? If I'm looking at this, the other thing I would maybe think about being able to calculate is if I had wanted to build my confidence interval, we kind of already went through this, but if I asked you to construct the confidence interval and I gave you the coefficient and the standard error, how would you do that? Well, get my upper bound, I take the coefficient and I add, well, it depends on the level, right? But I would take one of those 3 values, 1.65 for 90%, 1.96 for the 95, 2.58 for 99. I would then add that times the standard error to get my upper bound. I would then do the same thing, but I would subtract that value times my standard error to get my lower bound. So you could actually, even from this problem, try to reproduce those values. Try to see if you can get the 95% confidence interval using just the coefficient and the standard error, and then what should be that value associated with the 95% level. And I gave you the 3, those are the exact same 3 that you'll have. And I'll give them you just rounded to the second decimal. So you're going to be a little bit off from these confidence intervals here because I'm just giving it you rounded to the second decimal. And when it comes to the exam, when I'm grading these for partial credit, if you are doing something like this and you round this to the 3rd or 4th decimal, that's where writing out what you have, I can tell what you did and I can kind of grade it accordingly. I would say probably best practice, try to keep things out to the 3rd or 4th decimal. It will just make the grading go quicker for me. So I don't have to check to see if you did round it, what answer you would get. But in general, you keep things out to the 3rd or 4th decimal, you should be fine. It's not going to cause that much of a difference in the result that we see.
Can you repeat how the upper bound, lower bound's calculated again?
So we're gonna take that sample coefficient. We're gonna then add whatever level, confidence level we're trying to build. We'll take that value that would correspond to that level. Go that many standard deviations above to get our upper bound. Now here, we had a coefficient, our standard deviation is our standard error value. And then we'll do the same thing, but subtract to get our lower bound. And then I think that's. Right here, right? So that T value associated with having half of alpha, that's just gonna be those three values I give you, right? That correspond to our kind of three benchmark values of alpha, 0.1, 0.05, and 0.01. I would, first of all, are there any other questions that people want to see work through? Yeah.
How is that related to the sample mean? Again, like finding what you just.
So look at this equation. Then look at this equation. They're very similar, right? When we build confidence intervals, it's for a sample statistic. We're looking at the sample mean. I'm just going to be adding and subtracting however many standard deviations that are associated with the confidence interval I'm looking at, times the standard deviation of the sample statistic I'm looking at, which would be the standard deviation of that sample mean. If I'm doing it for a coefficient, instead of building my confidence interval around a sample mean, well, I'm building it around my sample coefficient. I'm still going a certain number of standard deviations to the left and the right to get my upper and lower bound. But now my standard deviation of the statistic I'm looking at, we call that our standard error. All right, so it's the same process. It's just that we're doing it for a different statistic now. Does that answer the question?
So for the sample mean, you use the standard deviation because it's given, and for the coefficient, you use the
Standard error.
yeah, standard error.
I would probably know how to do this data for a sample coefficient before a sample mean. It's the same process, but
It's different, like standard deviation versus standard error.
just a different word. It represents the same thing. It's the variation that exists in your sample statistic. You're just looking at a different sample statistic now. Yep. Any other ones that I might ask you to calculate?
You construct one of the like upper and lower bound. With what you just said.
Yeah, I mean, yeah. This, okay, so here's my output, right? Let's say I wanted to do the 99% confidence interval for income. What am I going to center that around? What value? So the slope coefficient on income is what? Negative 0.006. So I'm going to take negative 0.006 to get my upper bound. If I wanted to do a 99% confidence level, I said the value associated with that would be 2.58. I then need to multiply that by standard deviation of that income variable, which is what? 0.000, if I round it to the fourth decimal, 6, right? So 0.0006, that's my upper bound. How do I get my lower bound? I'm going to do the exact same thing, but I'm going to subtract that many standard deviations to get my lower bound. So I mean, you can enter these into your calculator, but like that basically would be the math in what you'd be doing. Yep. So just to be clear, right, these are two different values.
Just to be clear, the negative 0.006, that's zero, like it represents zero, or no?
Choose a different one. So if I'm looking at production, I'm building my confidence interval around the sample coefficient I find. These are all the sample coefficients I find. So if I'm looking at the production variable, I'll be building my confidence interval around what? 0.014 or 137. In fact, just to make this point, let's say I gave you the confidence intervals and I asked you what that coefficient is. I gave you nothing else. right? This might be a good thing to know how to do. What should be smack dab in the middle of all those confidence intervals? Every single coefficient. Well, if I have two values, how do I find the middle value? Add them up and divide by 2. So if I look for the middle value here, what am I going to find? 0.0137. So the way that I would get the upper bound is I would take 0.0137. Well, if I want the 95% confidence interval, I need to add 1.96 times the standard error of 0.0011 here. If I do that, I should get 0.01588. Yep.
Can you talk about finding the sign of a bias and actually how calculating the bias works?
Yeah. So where are we at in time? Oh, we're getting close. So I mean, these are important things to know. I'd focus a little bit more on some other things, which is somewhat worrying me. But one thing I would also kind of hammer home that we probably haven't spent much time on class doing today, but is going to be a pretty good chunk of the different questions. What do I ask you to do in almost every regression output? Interpret. You got to have these interpretations down, right? So you can have a dependent variable that is a dummy variable, 1, 0. So I would know all these combinations, right? I would think about, and then I'll get to your question because it's where we should do one like that. So you've got a dummy variable as your dependent variable. You can then have a dummy variable as your independent. You could have a dummy and continuous. You could have continuous and a dummy. You could have continuous and continuous. I'd be able to make interpretations for every single one of those slope coefficients, right? For every different combination. I would also know how to interpret my intercept. The intercept should be easy. Everyone should be getting this question right. Any regression, how do I interpret the intercept coefficient?
For every addition.
So if I've got an intercept, how do I always interpret that intercept coefficient? Not all else constant. 0. When every other variable is equal to 0, this is my predicted y value. Every single time. If I ever ask you to interpret an intercept coefficient, that should be an easy one. It's when every variable in that regression, whether or not it's a simple linear regression with one variable, or if I have 5 or 6, when every variable is equal to 0, this is my predicted value of the constant. It'll sometimes be weird, right? Because having 0 income or having 0 as your age is going to be weird, but that's always how we interpret that intercept. Now, in terms of interpreting the other ones, it gets trickier. If it's a dummy variable or not, right? A 1 unit change in a dummy variable is going to go from the 0 to the 1 group. A 1 unit change, if it's continuous, that should just be whatever the units of the variable are. And then we said when we're thinking about the dependent variable, the changes in that dependent variable, easy if it's continuous. It's just how many units the y variable goes up or down by. If it's a dummy variable, it's increases or decreases in the probability of belonging to the 1 group. So know how to make those interpretations. Also, if I have a multiple linear regression, what do I always need to add in to the end of my interpretation? Holding all else constant. Don't forget that. That'll be worth points, right? Should be easy points. If I see more than one variable in that regression, my interpretation of any of those slope coefficients should include holding all else constant. Okay. But to your question, these are worthwhile to think about. There will be probably 2 questions that look kind of like this on the exam. Where's the one in the practice problems? You know where it is?
Pretty early on.
Here it is. Okay. So this one, I don't even give you necessarily regression output. I'm just asking you for like an opinion-based thing. So this is where it could be right or wrong, 2 answers technically. Actually, there could be 4 answers, but I'll grade it accordingly, right? You would just have to give me support as to why you believe things are the way they are. So let's say I have this regression and I'm trying to predict whether or not a county kind of voted for the Republican candidate, so a dummy variable, and I've got unemployment and income. So I run this regression and I'm looking at the coefficient on income, okay? I think that it has a bias involved because I've left out an important omitted variable, which is the percent of the work in that county that is what we would call like production or factory work, okay? So if I'm thinking about a omitted variable bias, I should look at my formula sheet and come down here. Right, my omitted variable bias says, when I run this naive regression where I left out an important omitted variable, I'll pick up like the true effect of income in this case, but I'm also gonna include this bias component. What does the bias component is it composed of? So here's where I can give you a general form of the equation, but in the context of this problem, it's not saying use beta 2 from your regression. Beta 2 on this formula sheet simply represents the slope of the coefficient of the variable x2 that you left out. So we were thinking about the variable we left out was production work. So if we write down our bias, right? And this I'm just kind of copying down what that formula sheet had, right? This was the size or kind of the size and sign of our bias. This will be the variable that you omitted, right? This is the variable that you included. And then once again, x2, the variable we omitted, and here the variable that we included. The variable we included or that we were focusing on was income. And then I think the one we omitted was the percent of the work in that county that was factory work. So if I was trying to predict whether or not this county was a red county or a 1 if they voted for the Republican candidate, what do I think the bias would exist if I left out this important omitted variable? Well, if I did include it, I mean, this is one where you can give me a different story, but I think we would all probably, if we have, I try to choose examples where we'd all be thinking about it the same way. What do you think is probably true about counties that have more factory work? Stereotypically, if you think of factory workers, do you think they're more or less likely to vote for the Republican candidate? More, right? I mean, I don't know how much interaction. I grew up in a town with like a lot of people that, they're usually good old boys, right? They like to go hunting on the weekend. They like their guns, God, and So I had to imagine if I did include the percent of that county that's in factory work, I think that sign is probably positive. Now you could tell me you know factory workers and you believe that they're, open to all kinds of people and they want to push for progressiveness and you think that relationship is negative, that's fine. I'm not grading you on that part. You could tell me it's negative. I think it's probably positive. You could then say, okay, what is likely true about factory work and the covariance or that correlation with income? Well, are factory jobs known to be the most high paying jobs? No. So what do you think is probably true about that covariance? The covariance is likely negative. And then the variance of the variable you included in your regression or an income, variances are always positive. So if I've got positive times a negative over a positive, the sign of my bias here would be negative, right? Now, if you told me that you believed instead, it could be the case. I could be completely wrong, right? Show me the data and maybe I'm wrong, right? If I had a negative here instead, well, now the sign of my bias would be positive. Negative times a negative over a positive would be a positive bias. So if I ever asked you for the sign, you just have to tell me what you think. Give me, you have to identify first that it's the relationship of the variable you omitted with your y variable and what you believe that sign is, and then what you think the variance or covariance of the omitted variable is with the independent variable you included, and then that combination, would it produce a positive or negative bias for you? Now, I could also give you the regression output where I gave you what the estimate was if you included factory work, so you would know beta 2. I could then give you, see, I think there's one on here, maybe not. So maybe I do something like this. I then give you the covariance, right? And this would represent the variance of income. I could actually tell you now, if I ran the naive regression where I left out production work, what would the coefficient I find be? Well, the coefficient, right, should be whatever the true coefficient is plus the bias. Well, what would the value of the bias be here? Well, I now know the coefficient of that production, that omitted variable. I know the covariance of that omitted variable with income. I know the variance of income. I could plug those values in. and actually tell you what not the sign of the bias is, but also what the size of the bias is. So I might be very likely to do something like that. I give you a regression. I then ask you now in this one, technically, if you wanted to, what's the size of the bias? Well, if I'd given you the results of this regression, you could just compare it and see how much did the sign change, but I didn't give it to you, right? So I might give you the output that has the omitted variable and say, if I didn't have information on this and I ran that naive regression without this important omitted variable, what would the size of the bias be? You could tell me, because you know the coefficient of what that omitted variable would now be. You know the covariance of the omitted variable with the variable you're interested in income, and you know the variance of the variable that you would be able to include, which was income. Okay. Does that make any sense there? I think that one is actually, I don't think I actually asked you a question on that. So I'm glad somebody asked in class, because even though that doesn't pop up as a question you could be asked not just about the sign, you could be asked from this output to calculate the size of that bias as well. And we had the equation, now we've got the values, we can plug them in.
So to calculate that bias, would you just do the coefficient of production plus the correlation divided by the
Be careful. You wouldn't add it. You would take that coefficient and you would multiply it by the covariance, divide it by the variance of the variable you included, which would have been income. Okay. Is that what you're, does that answer your question? Yeah. I think we're running out of time here. Yeah.
For that, when would you add like what you have for the V1 coefficient?
So I could ask you two types of questions. If I simply asked you for the size of the bias, this is the bias. So you plug those values in. If I ran the naive regression, what estimate am I going to see? Well, I'm going to see that bias, right? Plus whatever the true value is. So I probably wouldn't ask you a question like that. I could ask you a question like that, in which case you could find the size of the bias, and then what would you add to it? The coefficient on income, right? The coefficient after you've included that important, because if I include the important omitted variable, what value should I see? If I include the omitted variable, the value I should see, I eliminate the bias, should just be what the actual coefficient is. So if I gave you the output with that important omitted variable included, the coefficient you see on income no longer has the bias involved. Okay? So you would just be seeing beta 1. So if you ran the regression omitting that variable, you would see beta 1 plus whatever the size of that bias is. I don't know that is off the top of my head without plugging those numbers in and calculating it. But yeah, you would take 0.006 and then add to it whatever that bias you calculated was.
Thank you.
All right, so I ran out time here, but next minute or two, any last minute questions logistically about the exam? So I wanted to mention one more thing before you get out of here. I have a chaotic day tomorrow, expected. So I will post an announcement as soon as I know what my office hours will be. Tentatively, I think they're going to be noon to 3. That is subject to change. Some of them might have to be virtual, but I am doing everything in my power to be in my office tomorrow for you guys from 12 to 3. Something changes, I should know later today, so I should have that announcement up before the end of the day today. Take a look early in the morning just in case, but I'm tentatively thinking that it's going to be 12 to 3 tomorrow is when I'll be in my office, which is a little bit different than my usual office hours. And just keep an eye on the announcements in case something changes. That is what I'm currently planning. Okay. All right. So good luck on the studying exam. I will see all of you here on time on Thursday.
Yeah.